Good morning, one and all. Welcome to the second day of National Level Online Faculty Development Program on current research trends in artificial intelligence and machine learning. I cheerfully welcome today's resource person, Sai Yaswanth Moorthy, Architect in Artificial Intelligence, Dartin Technologies, Hyderabad. I hope yesterday we had an excellent session by Lawrence sir. Today we are going to have an interesting session with practical illustrations. Now I request Rajita Madam to introduce resource person Sai Yaswanth Moorthy Garu.
Good morning, everyone. Myself, Rajita, Assistant Professor from Department of CSE. I'm very much glad to introduce you all about Mr. Sai Yaswanth Moorthy MN Garu, the resource person for our today's session. He has completed his undergraduation from Karunya Institute of Technology, Coimbatore. He worked in various companies like Smart Beach Educational Services, Hyderabad, BEL Bangalore, Infosys Limited, Mysore. He is presently working at Dartin Technologies, Hyderabad as an architect in artificial intelligence. Mr. Sai Yaswanth Moorthy Garu has profound knowledge in the fields of Python programming, machine learning, artificial intelligence, NLP, chatbot, computer vision, image processing, IBM Cloud, Alexa skill building. We are very much glad that we are going to gain knowledge from such an subject expertise person. Thank you, one and all.
Thank you, Rajita Madam. Now I request the resource person Sai Yaswanth Moorthy to take up the session.
Thank you so much. Thank you so much, Namrata Garu and Rajita ma'am. So this is a very good session that what we are doing right now, the national level online faculty development program. And I'm very much interested in these kind of activities as how you are interested in. And I would really like to thank every one of you who came forward to conduct this, AICTE, which has approved these kind of seminars to conduct, and the Department of Computer Science and Engineering, Gates Institute of Technology, a principal and the coordinators, and every one of you. I really thank you so much for attending these kind of sessions. And a very big heads up for all the engineers and all the professors working in computer science department as a first start, because we are going to rule the world. No matter what is going to happen to any resource in this world, what is going to happen in the war, what is going to happen for our resources, what is going to happen for the humanity, what we do in our daily basis is completely of artificial intelligence. And you guys have clearly understood these kind of things in yesterday's session. If I have to quickly recall about it, there has been various discussions regarding self-learning, regarding cognitive learning, and a very good example of Tesla and how face detection works, face recognition works in your mobile applications, and the existence of humanoids. How come a person able to interact with the chatbots? How come a person can interact with machines, and what the impact of that machines will be in the current world and the coming world, right? And how the medical field is going to emerge through these kind of technology. And not only medical field, a lot of other fields, retail industry, finance industry, medical, educational industry, our daily activities, supermarkets, all of these things are connected through a minimal amount of effort if you're looking at a global effort. Which means, why I'm telling it as a minimal effort, because you don't have to do anything to make the artificial intelligence work. You just have to provide it with food. The food is data. So the way you live, the way you think, the way you move yourself will provide the data for artificial intelligence, which ensures that it itself will help us do our daily activities better. So today I'm going to share with you a few of the simple examples, the very basic examples where you can start to think about a machine. The whole concept of artificial intelligence is how an engine or a machine starts to think about a human being. In fact, to make this happen, human have to start think about like a machine first. If you have to understand a person, you have to understand their perspective first, and then you have to make sure that your perspective is reached them very clearly. In the same manner, this communication has to be between you and the machine. So now we all basically know that a machine will understand only 0 to 1, 0 1 binary codes. But that's, it's beyond right now. It's been a very long time that people have discussed about 0 1. Now 0 1 has been developed into a lot of other things, and a machine now is capable of understanding your normal English letters and normal daily basic activities. How it can monitor your activities, it can see if your face is sad or if your face is happy or not. It can understand what you're feeling, it can understand what your thoughts are. Elon Musk, there was a great example yesterday that how how Elon Musk is trying to put up a chip in your brain, try to understand your neural activities, try to understand your brain functions. And these are all the evolutions, these are all the upcomings of a basic machine learning models. Right. So speaking of all these activities, I'm coming back to a simple machine learning algorithm. So if you can see whatever we spoke till yesterday or whatever I spoke till now, or a kind of over your head experiences. That means you try to imagine things and you try to think in a very broader perspective, which is shown in movies or in some Marvel effects. But as a person of computer science and engineering, what can you do about it? Is my first question. So, how are you going to try to solve these kind of things? How do you approach these kind of things? How do you implement this in your real world? Right? Yesterday, there was one more sentence called real world real world problems, real time problems which actually matter to the world. That was a really fabulous sentence that has been presented, and it has been taught a lot of lessons to the real world recently. Take some flight accidents, take some natural calamities, take some oil bust outs, petroleum pumps accidents, gasoline accidents, a lot of other things that could be managed if you had little bit of monitoring systems like AI. So why does all these things come from? From where do we start all these things? From where can we achieve the importance? From where can we start these kind of things? Is through basic machine learning models. So I hope what I'm trying to tell you is wide and clear. So now we can try understanding what machine learning actually means, right? So first things first, you have to understand the current recent activities that has been present in our real world right now. The first thing can be just a second, guys. So yeah, starting with machine learning, I am going to. I don't have any slides, any presentation prepared. My communication is sufficient, and it will be equipped with the things that you have to actually learn today. Right. So I will start with the basic terms like machine learning and data science. Machine learning, data science. What are the other buzzwords? AI, robotics. So coming to these kind of things, any person who is trying to understand what a machine learning is have to be familiar with what AI actually does in this real world, right? So when you are trying to achieve something in AI, what matters is data, right? What matters is data. So now the connection between AI and ML and the connection between AI and data science. This has been a very routing techniques where people start to figure out what actually is this or these terms. So now I will clear these things with simple examples and illustrations where you will try to understand what these things actually matter, when these things actually matter. Right? When come to robotics, this is a high-end feature where you can say combining all these things and integrating it with a certain level of expertise. there comes robotics. Okay. So how this can be achieved is, when you talk about machine learning generally refers to the kind of teaching that you are giving to a computer, right? Let's talk about it. So now, what do you mean by teaching? So now you try to understand something, now you try to, go to a person and you try to explain him new things. So what do you try to tell him? How do you start telling him? So you try to give an example, you try to give him some illustrations, you try to give him some results, right? You try to connect with things that he already know. For example, if a person got an automatic washing machine, he doesn't know how to use an automatic washing machine. He might have used a regular based, manual washing machine. Now you have to tell him which button has to be monitored to make sure that the timing is set right, make sure that the spinning is set right, make sure that the water level is set right. So these are the things that you relate to the previous person, right? So what will happen here is you basically try to give some examples, which we call it as data. Okay, so these examples, which are nothing but a data that for a machine learning model. So now what happens, it will try to understand these examples, it will try to calculate, or it will try to analyze these things what has been given as a data, right? And then it will try to understand what can be the next. So if you're going through the same route again and again, you first time you might have come across one speed breaker unknowingly, you have bumped it. The second time you might have understood and you might have slowed down a little bit at a very nearest point. The third time you might have taken care, 5 meters ahead. The next time, or the 10th time, or the 11th time, what will you do? You might have came across some shortcut where where you can skip that speed breaker. That's how we do, right? So what is happening here, it is just a flow of understanding, the reinforcement learning that has been spoke about yesterday, which means you will be getting certain kind of points, you'll be understanding that okay, the speed breaker will actually give me certain kind of hurdles to the bike as well as me, right? So the data is flowing, you are flowing through the data and you are getting some points, positive or negative points. That's a different level of story, but what is happening here is you are trying to understand that there is a hurdle, there is a speed breaker over there. So the next time you go, you will understand that there is a speed breaker and you try to predict that it will be coming in the next 10 meters, in the next 15 meters. You will try to apply a brake previously. So this is a mechanism that we have to make sure that the engine or the machine understands these kind of activities. So as a human being, we understand, or we tend to think in a perspective like a learning pattern, from the age of, from the grade, from the 6th grade, 7th grade, you actually start thinking about, the predicting things, you actually start feeling things emotionally, you try to predict stuff that you actually want to do, what parents are feeling, what you have what about your friend, about your teacher, a lot of activities you've been doing, about the sports, about the studies, about the food you eat, about the dress you wear, the places you want to go, the things that you want to read, the movies you want to watch. These are all the data that you have been accumulating since your 6th grade, right? From some certain point, you tend to restrict yourself to few things that you think that you like it. So how do you think that you like it? Because it gave you certain kind of nice feeling, that is a plus point here. If it is likable for you alone, it may be not a likable thing for other people, right? This is called as a perception. Here we call it as recommendation engine, right? If one individual is gonna like few things, and it not necessarily the other people also have to like it, right? These kind of same replication is introduced in Netflix, Amazon, and all these kind of e-commerce platforms and social media. So the news feed that you are seeing, the social media feed that you are seeing, the movie suggestions that you are seeing are particularly to one person perspective. And how is this gonna get developed? So the how you started liking things, how you started recognizing your likables. The same way, the engine is trying to understand your own likings and your own favorites. So this is accumulation where I'm trying to figure out the connection between your own thoughts and the machine thoughts. So how is this gonna be achieved? How this is possible in practical manner? Let's see in a few minutes. Before that, I want you to understand the basic logics behind this. So the human intelligence, what I am talking about, all of these concepts are called as human intelligence. The human intelligence is nothing but the way the humans think. Simple as that. So this human intelligence is been established from centuries together, and people don't actually appreciate it, right? People, we think that it's nothing more, it's nothing, that's what we are, that's what we think. But when you try to figure out the basic mechanisms behind it, and when you try to make sure that engines are going to learn these kind of thoughts and engines are going to implement these kind of thoughts, then you will understand the difficulty or importance of the human thought. Now you think and you make a prediction, you understand as quickly as possible. A small baby will understand to call mama in their 1 month, 2 month, 3 months period sometimes. And the mechanism that has been involved over there is very simple. He is seeing the parents and the people who they are speaking beside them for days, for months, and they try to replicate things. They'll try to start bubbling few words. They'll start walking few miles, and they start their baby steps, they start their baby words. How does that happen? It's as simple as that: observing and learning, observing and learning, right? So what is the observing capacity of a machine here? How can a machine observe things? How can a machine grasp things? It's purely an input. We call it as an input. Input in different forms. There is input of a text file, input of Excel file, input of video file, input of voice files, input of live streaming, input of a lot of things. Whatever you give for your machine is an input, and any input can be transformed into a learning pattern, right? You see things, you feel things, you touch, right? Using all your senses, you hear some things, you taste something. All of these things are input for your body, for your neural network, for your human brain. So now your human brain will understand the difference between each and every smell, each and every taste, each and every touch, each and every feeling that you are getting. How does this distinction happen? So every time you smell something good, it will produce some kind of good chemical in your body. It will produce a happy chemical in your body. So that is a positive point for your brain, and it will understand, yeah, I like this or I don't like this. So there you are trying to figure out what kind of, or what category of things that you actually like and what category of things that you don't like. All right. So in the same way, for the engine to produce, you have to have a target. In your human case, there might be some enzymes producing when you are happy about it. There might be some enzymes producing when you are reacting very good towards it. So the output is the brain that is being monitored. But here for the data, we give something called as targets. So sorry. So now our brain will have this kind of enzymes and all that things, but as a machine, we have to produce some kind of targets. What are those things? So for certain for particular scenario, for particular data, there has to be one plus or minus. There has to be an indication where it is successful or not. There has to be an indication whether it is acceptable or not. There has to be an indication whether it is profitable or not. There has to be an indication where it is true or not. So these kind of indications will help data to understand whether under particular condition, under certain conditions, do we have to approve this or not? Do we have to accept this or not? So everywhere you go, there are only two things: yes or no, positive, negative. true or false. So even machine has to be taught in a such a way that when a condition is getting prolonged, when a condition is getting given, when a data under some circumstances has been given, so whether we have to accept the data or we have to let the data go, do we have to take any action on the data or should we just let the data go? So this is the first confusion, first if else confusion that any kind of machine will be having. So if the data is so and so, so and so, so and so, should we do this particular action or not? If the data is something else, so what is the type of action we have to take? This is a basic understanding of any kind of data, right? So now these are all the things that are basic in machine learning. So what is data science now? Right, so the understanding that I have just shared with you, all the things that the capabilities that a machine has to undergo, the flow that any learning pattern has to follow in order to make sure the machine will understand these things, is all comes under machine learning, and it all depending upon few parameters, few conditions, few situations, few data, right? So now let's come back to data science. This is a very fancy term. This is, like, people have very misconceptions of what actually data science is. They really tend to understand or really tend to confuse between machine learning, data science, and data analytics. So data science is a very sophisticated field, a very mature field, or a very safe play field. It doesn't have any errors, it doesn't have any false negotiations, it doesn't have any disrupted data, disrupted outputs or something. Machine learning can be false sometimes, because if the data is wrong, what can it learn? If the boy, if a girl, any person is given a wrong set of information, if they are taught in a wrong way, they obviously learn in a wrong way. So the same way, if we give a certain kind of wrong data for the machine, it will try to understand or it will try to predict the wrong results. So there are chances of machine learning to be failed. But whereas data science, it's like a wise person, it's like a master about all these things. It try to analyze things, it will try to understand things, and it will just give you a summary. Okay, it will try to figure out what things are, but it will never try to judge anything. It will never try to do anything about the data. So data science basically does things like analysis. It will give you some reports, it will give you requirements, it will make you understand what data is and how data is flowing, the data patterns inside it, the data variance, right, the statistics, all these things combined together, a visualization effects. Data science actually gives you a push up towards machine learning, towards machine learning capabilities, to make sure that a algorithm is running good, right? Without data science, you cannot ensure that machine learning is good. Without machine learning, you cannot ensure that AI is good. So without all these things, you can never ensure that robotics is good. Let me come back to that. So now the data science field. The data science field will give you the emerging data, the data that has to be managed. So the data engineering, the data selection, you have these kind of terms. Okay. So which means the first of all, you see a bunch of movie things. You went for a movie gallery. Nowadays there are not much movie galleries, but previously there used to be galleries where thousands and thousands of CDs used to be there, and you go there and you take a CD, come back to home, play the DVD in your home screen or something. So now what is happening there? You went for a movie gallery or CD gallery. There you have multiple options. You try to categorize things, you try to understand which movies you like, you try to figure out rom-com, action, thriller, adventure, what kind of category, how much time do they take, who are the players inside it, who are the actors inside, and what genre do you like. So these are the preferences that you're trying to make. But what actually you're doing there, you're categorizing things, you're understanding the requirements over there, you're understanding the present data, right? You go there, you see them, you categorize them, you figure out a couple of things, and you get them back. So now the result is one or two CDs that you bring back to home. But what is actually happening there? A lot of algorithms in your brain, right? So this understanding that a brain is doing before you tend to have some results before you figure out something, before you start categorizing, before you give some ranks, before you say I like this, or before you say I don't like this. The kind of understanding that you are giving for yourself, the kind of understanding that you and the movies have, right? This understanding is nothing but the data science. So this understanding have to be replicated in a machine to make sure that data has been connected with the machine properly. There will be a lot of data, big data is there. For there has been a very vast development in technology, so that for every person, for every day, you are at least generating 250 GB of data, every person. So now, using all this huge amount of data, it is very difficult for any kind of machine to understand what is actually happening inside it. This data science is a field that will allow you to look in a perspective how to integrate that huge amount of data into some kind of reasonable formats. Then those reasonable formats will be taken to machine learning to understand it. Now you got a picture, I guess. So data science will be having full deviations of data, or lots and lots of data. It doesn't know what actually is happening inside the data and all those messy data around it. Now it will try to figure out a solution where it is capable of understanding what actually is happening before you actually learn something. You went for a football, maybe badminton. I'll use badminton because it's my favorite sport. So you went for a stadium and you will try to hold a racket and you will try to take a shuttle in your hand, and the first time you take your shuttle in your hand, it's very difficult for you to pull out a smash or pull out a drop. You go there, you try to figure out how people are learning there and all those things. But initially, the first feeling that you get the moment you enter over there, the analysis, the type of analysis, the type of huge data you have. So like there is someone called as coach, there are 4 players playing, there is something net in between, a lot of people are coming here and there, they're going, they're running, they're shouting some scores. There is sound, too much of sound you don't understand. People are screaming, people are appreciating few people, and people are shouting at others for doing wrong points, and lots and data are there in one badminton court. What do you do there? You're the person who went for the first time into that court, badminton academy. So now you try to look at all the things, but actually what actually matters there, how a person have to play, is the only parameter that matters over there. So that pattern, that playing part which is there, is called as machine learning. So the moment you enter into your code, how you try to, you'll be very confused with a lot of things. This confusion part and the point where you figure out what actually matters in between whatever is there is called as data science. So the moment you have large amount of data and you don't have any clue where to start the learning, so now some person will come and he will try to explain things to you. So this is called code, this is called shoes, these are called rackets, these are called shuttles, right? So this is how you start playing, this is called a serve, these are called points. So this is how you oppose an opponent, like he start to explain new things. But is it the learning, is it the learning that he's trying to explain to you? No, it is not the learning. He's trying to explain to you what is there inside the badminton court. That's all. He's not trying to explain you how to play. He is not giving you an experience of playing. The experience of playing is machine learning. But the understanding that you have towards the game, towards the court, towards the person who is playing, towards the score, the understanding that you have is data science. These both things take a very good deviation in the current technologies, because there are multiple applications where you can just sit there and understand and achieve a lot of other things. Some places you have to make an action, you have to perform some action, and you have to predict something, you have to learn something, and you have to purchase some patterns in order to give some results. So this is where machine learning comes, right? Few places you don't have to, you know go to a result. You don't have to be in a result format. You just have to understand stuff and be there as yourself. For example, when you are going to a movie, do you have to do anything in a movie? What is your part in a movie? You just have to buy a ticket and sit there, right? Whatever comes in your screen and goes in your screen is not at all your part. It's something about their part. So there, your action is to just sit and observe and come back and give a comment. Movie is good or not, good or bad, right? So based on your reviews, somewhere in some other city, some person who you don't even know will try to change their acting performance. So that is their machine learning problem. So they are giving you their own performance, they're giving you their data and asking you how it is and seeing for your results, seeing for your output. So what you are doing there, you are doing data science over there. They are doing machine learning. Got it? So your part in movie theater is, as a participant, as an audience, is to do data science. But as per the actors or actress, whoever is there inside the movie, their part is to perform machine learning using your data science outputs. All right. So these things matters a lot when it comes to real world. Now coming to AI. I hope you have got a clear picture about how machine learning and data science are related and what brings them together and what is the distinction between those two clearly. Right. So now AI, it's like the master of all these things, the master of machine learning. This has deep learning inside it. This has reinforcement learning, machine learning, and a lot of other learning techniques which we don't even know. All right. AI is very vast that it can learn anything from anywhere. Okay. So machine learning has to have some rules, some kind of responsibility, some kind of conditions, right? Machine learning has to have some kind of conditions. So machine learning will have examples, targets, and conditions, whereas AI can learn from anywhere. Learn from anywhere and anything. So whatever the data it is, whatever the type of data it is, wherever it is, AI is capable of getting it. You know, based upon a lot of other forms. But whereas machine learning have to have some examples behind it. It has to have some targets. It has to have some conditions in order to learn something. If you have to learn badminton, you need to wear shoes. You have to hold a racket. You have to understand the score pattern. You have to you do have to know how to serve. You do have to know when to come out of the court. You do have to know when to step in, to actually hit a smash, and when to avoid hitting a smash, and all these things are based upon some conditions. So this condition oriented learning which is there is called as machine learning. The analysis or the introduction towards the data is called as data science. So we can say introduction towards data is called data science. And the type of understanding that you have based on some examples, targets, and conditions is called as machine learning. And AI comes from a place where it can learn anything from everywhere, right? And learn from anywhere and anything. So now all of these things combined, robotics or intelligent machines. So now it will take the understandings of AI, it will take the conditions of machine learning, it will take the understanding of data. So now what is happening here? What does a wise person do? Wise person will take the recommendations from others, he will take the experience of others. A wise person will never sit and experience things for himself. He will always rely on other people's experiences. So now robotics are such a term where all of these things will get um deployed, will get integrated into one single platform where an input and output and understanding will be in the same phase. So now if I can say input output. So in between input and output are nothing but results. So you have a picture where what does an automation mean? You have to switch off your fan, you have to switch off your light. The moment you leave out of your room, fan has to be turned off automatically. The moment you move out of your room or house, the lights have to be turned off automatically. So these are the results. What is the input? You moving out of your house or moving out of your room is your input. So understanding what it has in between you moving out of your room and lights getting switched off. So in between these things, whatever is happening, does it involve some kind of mechanisms? Does it involve some kind of mechanics? No, some tools, some kind of robots may say. No, robot may not be a Sophia. Robot may not be, a full humanoid robot. Robot can be a simple smartphone. Robot can be a simple device, simple Raspberry Pi, simple Arduino, or simple sensor that can perform some kind of action that human is supposed to do. And now, in place of human, it is giving you the output. Right. So now what do we have before between input and output? We have learning, then we have execution. So what does an execution mean? The pattern that you involve in order to switch off your fan, that you left out, that is called an input. So when you move out, you have to switch off. There has to be a program that will allow fan to get turned off. This is that how you move out of your home. When does it mean that you are out of your room? You might be moving here and there, but that time it should not turn off. It should only turn off when you actually are out of the room. So there is a difference between you just moving and you're just moving out of your home. It has to understand which means what. So this is kind of learning that you are giving for your bot or for your robot, right? So now it has to execute an action. It has to undergo some process, an execution process where that moving out input is getting carry forwarded to some kind of electrical equipment, electrical switch. So this movement of data from an input signal, an input sensor signal or input visual signal to electrical signal, this is called an execution. So what is the output? Your fan getting turned off, your light getting turned off is your output. So this is a real time. This is how you make a real time application work using your understanding, using a machine understanding, using machine learning, using artificial intelligence. You have to switch off your fan there with human intelligence, but you are too lazy to do it. You are relying on some artificial intelligence. You have to eat your organic food, but you are too lazy to get out and get your organic food. So you're purchasing some snacks out of your supermarket, which is an artificial flavor. Now you can relate it, right? So this is how an artificial intelligence is getting boosted, but this is not the actual way to look at artificial intelligence. We are not lazy, we are getting proactive in the field of AI. We are getting proactive in the field of robotics. We are getting proactive to go to moon, to go to Mars, to make sure that human is getting a vast amount of valuable time instead of spending on small stuff, doing things regularly, daily to day by day basis, again and again. How much time do you think it will take to wash your clothes by your hand, to wait in front of washing machine, to wash your dishes, to make sure things are getting organized, to make check your home, all the lights and fans are turned off, to arrange your home, to decorate your home. So you can work on yourself. You can work to make sure the community is better. You can go and solve some real life human problems. Half day will be wasted if you just sit in home and make sure things are all right and doing all those things by yourself. All those things, it is very good example or a very good platform for all the homemakers and all the people who are struggling to make their day-to-day basis, a very hard situation. They can use this AI and make sure that they are working on their own. They are doing something better for themselves. They are doing something better for the community. They're doing something better for humanities, or for maybe aliens, in future, if someone present, right? So these things actually make our lives better. Okay, so now I'll try to introduce you to the field of machine learning, how you start to understand a use case, and what actually is happening here. I hope uh, whatever I have just told is a very simple glance of things, and I think I am ready to go for the next step. Am I? All right. So is my screen visible? Okay. All right. So I'll start explaining you the understanding of machine learning in the first place. So before you start, practical implementations, or what we can say, how actually a machine learning works. As we all know, it has to come from a programming. Now let's say we have a basic Python programming, and we have to be ahead of few algorithms. Right? This is a basic requirement of any machine learning project that you are going to take. Or I don't call it as a project, guys. It's not a project. It's a machine learning model. It's an application that you are trying to produce for the humanity. You just have to think in that perspective every time you're going to do something in machine learning. You're not here for a one line output. You're not here for something, we got some answer, we have got some output, we got some results, and done. So the machine learning itself has a very good impact in the community or the atmosphere around you, where if you start learning how machine learning thinks, you tend to see things differently. You human will understand things very deeply. I have practically practiced it a lot, and I love being in these kind of thoughts. I go outside, I see people wandering here and there, I see a supermarket. I try to think like how a machine would think in this point of view, how to make sure that this understanding that I'm having right now, right at this point, can be transferred into a machine, and make sure that any robot that is present on behalf of me will understand or will do the same thing as what I am doing right now. So how can you transmit that information from my brain to such a kind of mechanic environment in the robot? So this kind of perspective got built up to me, and now I cannot see things as they are. I always see things as a artificial intelligence architect. I see things in a better world, to make the world better, right? I don't have to worry too much. I don't want any person to sit there and monitor the traffic over there. It has to be automated. Why does a man has to struggle there in traffic, pollution, heat, in cold weathers, in rainy season? He also have some family, he also have a lot of things to do. He doesn't have to sit there and be there in that kind of extreme weather conditions to make sure that people are going right. Right, he doesn't have to suffer. A human cannot be suffered in that kind of environments if it is too much to suffer. In cities like Bangalore and Mumbai, we see a lot of traffic people struggling towards controlling the traffic and making sure that people are going in the right direction, wearing their helmets and this and that and so many things. Why should a person have to suffer going through all these things? Right. So now if a machine learning machine has to be replaced in the place of them, how can it understand the real world implications? So whenever you go outside to a traffic, whenever you go out in hill climbing, or whenever you go come across a problem, just think like How can we solve it by making it automatic? How can we solve it by introducing this problem to a machine? How can a machine solve this kind of problem instead of we sitting and struggling towards it? So these things come gradually. Basically, now if you want to make sure that a machine is trying to understand it, we have to go to a point where we know the machine language. So for all of us, what we basically know is a language called Python, which we can use to integrate our knowledge to machine. So this Python, I'm using the Python as a tool to reach out to machines and talk to machines. Right. I know English and I'm able to speak with you in English. I know Python, I can speak with machines in Python. As simple as that. I'm trying to explain it. Dude, you just don't have to do this. You just don't have to learn it. Bro, this is good. So like go with this machine. I'm trying to speak with a machine like that. I'm trying to guide a machine there. I'm trying to talk to a machine like how I speak with you. For that, I use two things: language and algorithms. Language is to create a communication, algorithm to make sure the point is going right, to make sure that it is understanding things. No, it's not just for communication. Python is for communication, algorithm is for understanding. Got it? Any language we can use. Python works, Java works, C works, COBOL works, maybe Go works, and a lot of other things are there which are better in communicating with the machine than Python. Right? But Python is open for everyone, and a lot of people know Python dev nowadays, so we use it. Now coming back to things that are involved in Python. So what do you have to understand about it? Basically, you just have to know some basics and how to assign and manipulate data. So why does this is very important? Mm, you go to a shop, IKEA, or any kind of supermarket, and you want biscuits. You go there and purchase some rice, right? So in your home, you want to prepare dal. Do you go and cut meat? No, right? So you have particularities about what you have to do and what you have to make in the first step. So when you want to use certain kind of information, you have to have the control of assigning and using the data. So how to use the data, how to manage the data, how to control the data flow. These things will happen only through Python assignments and Python data manipulations. So what you are doing here, you are controlling your information, you are controlling your data, you're storing your data in some variables. Is it? You're using your variables, you're using your functions to control the lead or to make sure the data flow is perfect, right? So now again, Python for data science and data analytics, this is a very different point of view that you have to start using Python for, because there is Python, advanced Python, there is Python for you know applications, mobile applications, Python for full stack Python. A lot of Pythons are there, but the Python you have to use is for Python for data science and Python for data analytics. This Python involves Pandas packages like Pandas, Matplotlib, SkyPy, NumPy, and a few other calculation packages. Why do you specifically mention Python for data science? The field of data science is taking help of Python to do some actions, but data science separately has a lot of other things to do. Python separately have a lot of other things to do. The integration between Python and data science is only helpful to make sure that the system is learning good in certain kind of aspects. So Python for data science and Python for data analytics is the only perception you have to start understanding when you are trying to do some kind of machine learning or artificial intelligence. This will help you to get the basic idea about how to get introduced to a machine learning models, how to start with machine learning models, how to deploy machine learning models, and basically how to understand the data. Once you start understanding the data, this Python will help you to look into things of data science deeply. Now you are ready to go. You're ready to start your process. Now you are good with your understanding. You go for machine learning models, model building. So in Python, you will come across function deployments. You might have done some mobile applications. You might have seen how you host a website using Python.
Excuse me, Sai Garu.
Chepandi.
Sir, have you changed the screen or the same old screen, sir?
Okay, this is a different screen. So, all right, thank you so
So
much.
from the past 5 minutes, it was the same old screen. Yeah, now it is visible, but can you please zoom that slides or the screen? Sir, your voice is not audible.
Hello.
Yeah, Sai.
Yeah. Hi.
Yeah,
Is it fine now?
yes, it's fine.
Thank you
I
so
can start.
much. Thank you so much. So the understanding of the example that you're taking into picture, the consideration of the example, Now, why are these things important? How does this actually matter? Because no, you just take an example of what we have been discussing since 1 hour. So if there was no example, what I'm trying to talk to you, if there is no scenario where it can be related to you, if there is no movie example, if there is no washing machine example, if there is no example of your own child, if there is no example of something that I'm just mentioned, do you, or how can you at least approach towards the technicality that I am trying to explain to you? So how can you understand is based upon the example that you take in machine learning, right? The use case that you follow up, or the problem statement that you relate yourself to. So now what happens is, in that example and the data you actually have, you have to understand why these kind of row. So whatever the data it is there, can be converted to Excel files, it can be converted to text files, it can be converted to video files, it can be converted to any other formats. So here, when you're talking about Excel files, for example, you have to understand what does that column represent. If you're talking about video files, you have to understand what one clip or 1 second of that video consists of. Now, what is that you are going to achieve when you are holding that picture to yourself? What is that you are going to relate the problem statement to? What is that in your data that is so important that you have to use it for the model? So what is that in your data that is affecting the real world, that has been taken from the outside parameters? So this is called understanding. This understanding helps you to make sure how to use those kind of data and where to use that kind of data. So next comes data flow understanding. You have understood the data, right? You know the destination where you want to go, right? The first step is to know where you want to go. You want to go to a mall. Yeah, fine. You have decided, you know mall, and you have some examples, and there are some movie theaters, shopping malls, and this, then that in the shopping mall. So now you have to reach there. You have to make a map towards it. So you have to understand what are the steps to be involved to making sure that the data is moving from one point of the model to another point in a proper way. I'll explain it to you. So first of all, you have some raw data. Okay, now you understood what the raw data is and what is the meaning of the data in the real world. So now you have to come forward to understand what are the changes that it has to take place in order to solve this problem. So you have some temperature, maybe for example you have the temperature issue in your house, or if you are living in some Iceland, Greenland, or somewhere in your in other states, you have these temperature issues, right? You're looking at the outside temperature, it has to control your home temperature. So now what is happening here, based on the data that is available, it has to keep changing the parameters inside the home. Right. So in any action that you take, once you understand what is happening there, if you're in a fight, you are the person who went there and you are trying to solve a fight. What do? You try to understand what is happening on both the ends, and you try to figure out which point is what and what is happening there. So this is a data flow that is happening towards it. Right. So next, what happens? You try to use some kind of methods. You try to use some functions. You try to use some algorithms towards the data. Getting my point? So first step, you try to relate the data towards the real-time problems. Then you try to understand what are the changes that has to be made to the data to achieve some solutions, to, to, to resolve the problem, to create some solutions. What is the process that you have to undergo? So what is the data flow that has to be taken place to make sure that a solution is got and solution got right? So that is called data flow. And next, to this data, how are you going to approach it? What are the methods you are going to use? What are the algorithms you are going to use? So this is a very important step, because whatever the understanding you have, only algorithms have capability to make sure this data has been monitored by the machine. So I just told you before, Python language is a tool of communication. Algorithm is a tool of understanding. So if you want to make sure that the machine is learning something, the key tool is algorithm. So once you relate your real-time data to your problem statement, and once you understand what is the flow of the data that has to be made, you have also triggered a certain kind of requirements for the algorithm. So which algorithm you have to use, and what are the features for it, right? The moment you are done with all those things, right? So now there are a lot of other mechanisms that has to be performed, and a lot of other algorithms, similar algorithms that can be performed. For example, while grouping, you have multiple grouping mechanisms. While predicting something, you have a lot of functions to predict. You have a lot of algorithms to predict. But in this particular data scenario, in your current scenario, what is that you have to do? So which type of algorithms you have to use? What is the prediction mechanism that has to be involved in those things? So this is how you decide in a granular level, which means you have to bring down one step and you have to fix to one algorithm or fix to a couple of algorithms to prediction. So next comes the very important thing of all the things that are happening in machine learning and artificial intelligence, that is called features and effects, right? So now what are these things? What are the features and effects? This is the only thing that actually matters in machine learning. I'm telling you, features are the only thing that actually matter in machine learning. Without features, there is nothing you're going to learn. There is nothing a machine going to learn. There is nothing that can be predicted, that there is nothing that can be solved. So what are these features, or what are these parameters? The data that you give for the machine to understand in some particular condition. As we spoke before, there has to be one example, which is a data example. There has to be a target, which is the solution, and there has to be a condition. Those are features. So when you have these things, when you have these features, and when you have these features aligned in one condition, only then your output have some meaning. All right. Only when you have the parameters aligned in certain kind of condition, your output have some meaning. So if you do not have your parameters aligned, or if you do not have your features combined together, the result is suspicious. You can never predict what is going to happen as a result field. Whatever it may be correct or wrong, it may be predictable or unpredictable, you don't know. So to make sure that the result is going good, you have to make sure that the features are right. So now this is regarding your technical side of your machine learning. So now what I have discussed till now is why Python is involved in machine learning, how you have to approach towards the data, or you have to start understanding the technical requirements of the machine learning. You have your data, you started to do the project, or you started to do a use case, you started to find a solution towards it, and now how do you have to start learning the data, start using the data towards machine learning, is the second point I have discussed. So now coming to machine learning point of view. So now I am a new person for machine learning. Now what I have to do inside machine learning is you have to understand use case. So okay, so these are the features. So once you are clear with the features, what are the features that are required, and important features that matter, and a lot of other things. Now, okay, you have these things. Okay, yeah, okay, you have 10 colors in your hand. You have pens, you have color pens in your hand. So you understood that this is red color, this is green color, this is blue color. So what? You have to also know what picture you have to draw. Just because you know the names of the color pens you have in your hand, that doesn't mean you can draw something. So you have to also figure out what type of image you have to draw next. And do you want to put that image in your gallery, or do you want to sell it to a museum? Do you want to make it as a historical event? Are you are you going to present it in an event? Are you just gifting someone? So this is the usage of the data, right? So the moment you have your pens in your hand is called the features. Even like you have color pencils in your hand, so that is the importance of future, because without color pencils you're gonna draw nothing. You cannot draw anything. So the first point is to understand the types of colors that you have in your hand, and the next important thing the artistic form or the learning form or the machine learning thing that you have to do is to understand which type of picture you have to draw there. What do you want to draw there? What is the use case given for you? What is the problem statement you have? What is that you are going to solve? Right? Just because you have your data and you understand the importance of the data, that doesn't mean you understood what you are going to achieve it. So first things first, you have to understand what you are going to achieve, then how you are going to achieve, and there comes data science, right? So the data science forms comes into picture in dataset formation and visualization. So now this involves few forms of data science where it will tell you to understand the data, right? It will tell you to visualize the data, it will tell you to categorize the data, it will tell you to follow the requirements of the problem statement. So now you are ready for model creation, and once the model is created, you are ready for the deployment. And what does deployment mean? Deployment mean it you have taken this complete algorithmic solution or complete algorithmic response or the result to the real world. Increase in the temperature, decrease in the temperature, switching off the fan, switching on the fan, right? Predicting some outputs, classifying something, movie recommendations. These are all the things that are being deployed somewhere. Someone have came across all these things before they actually are implemented, right? So before you start to make these things in real-time applications, these are things that have to be involved before you start doing any of those things. So now we have a lot of applications for those things. Let me just share with you the applications of those. So extensions or integrations, which means this is a format that has to be followed for any kind of problem statement in AI. For any kind of problem statement, for this is the basic model of how you're gonna approach towards AI. Now, what are the types and what are the extensions of it? Natural language processing. The first thing is how to communicate as normally as you speak with other people with the computers. The second thing is computer vision. So a person, what does a person have? Just let's start from here. What does a human being do? Human being communicate, human being observe things, human beings recognize other people's voice, humans recognize places, humans recognize things, humans see things, right? So all of these activities involved together, we are going to present it to machine. So first thing, natural language processing, the way we speak to one another, we have to speak to a machine. So the involvement of all the logics and the approach towards it are getting packaged, and we call it as natural language processing. So the approach, we get to observe things, we see things, we understand things. Okay, this is a room, this is a hill, this is a ocean, this is a place to vibe, this is a place to go for drinks, this is a party place, this is a wedding, this is home. So these are the observations that you make through your eye. So a vision is required for this. So in order for a AI algorithm to understand these specifications, in order to make sure that a machine is able to distinguish these events and understand these events, computer vision. So human vision, computer vision. So how we are gonna visualize things, we are going to observe things the same way computer has to observe things and capture those things and understand it. There is a again, so once the vision has been captured, these are all the things that are getting involved inside the machine learning process to make sure that they are going to predict that whatever they are seeing is right. If they're looking at a bottle, they have to machine has to recognize it as a bottle. If they're looking at a laptop, they have to recognize it as a laptop. So what are the steps involved? Again, coming back to these things, right? Same thing as speech recognition, image recognition, and inside web development and cloud development, you know that comes like e-commerce and recommendation engines. Web development is nothing but the approach towards e-commerce, shopping, Amazon shopping. The recommendations that you get once you purchase a phone, you're going to get a lot of other phones, maybe a back case, maybe a charger, maybe earphones. So these developments in web applications using machine learning and cloud technologies. So whatever you're gonna use these days, whatever is going to be developed these days is gonna get deployed in cloud, right? So the other point which we can say is integrating these machine learning models to cloud will ensure that whatever model you have built is available throughout the world and to everyone around here, right? So these are the basic integrations that you have to keep in mind before you start your machine learning, where you want to approach it, what is the use case that you want to do. Is it a general machine learning application, or is it a natural language processing, or is it a computer vision approach, or is it a speech recognition, image recognition, or do you want to upload it to a web application and integrate with web application, or you have to manage some cloud equipments, right? So this is a bigger picture of what you're gonna move towards. You're starting with certain kind of basic principles of basic Python operations, and where are you ending up with? You're ending up with some natural language processing or some cloud deployments. So this flow, whatever is there, is it's just not that easy to capture these things and understand these things in one go. But it may seem a little bit naive to you, or it may seem a little bit, what is this that this fellow is telling you. But if you observe things clearly, whatever I have just told you, it takes a lot of time to figure out for any people to actually come there and sit and understand what comes next. You have the data, so what do we have to do next? You have a lot of courses together, you have a lot of things together, but they do not explain how you have to think towards it, right? You have to think towards it like a machine. You have to think towards it with smaller steps to approach. So these are the steps that I follow myself in doing any project that comes to my hand. So enough of the prep talk right now. So now let's go back to some of the applications, I can say. Just a second. Yeah, let's see the steps involved while performing some operations. All right. So clearly I can use around 10 steps. So I'll be very quick about these things, because I hope you guys have already got a very clear picture about few things that I have just mentioned. So the first things first, what you have to make sure is how you get your data inside it. How do you start creating data? The first step is to extract the data. So as I told you already, it can be from websites, IoT applications, databases, Excel sheets, local drive servers, manual inputs, text inputs, CSV files, anything, anywhere. So now you have to integrate websites with your Python, IoT applications with Python, databases with Python, Excel sheets with Python, local drives with Python, servers with Python, manual inputs with Python, text files with Python, CSV formats with Python. Because Python is the communication platforms towards you and your machine. So any data that has been stored anywhere has to be integrated with Python in order to extract the data into your kernel, into your working platform. So the first thing you have to do is to extract the data from any source available, depending upon the project, depending upon the use case, depending upon your result that you want. So once this step is done, you have to start making sense towards the data. It doesn't you just have a full basket of rice and you just can't cook it directly. You have to clean it, you have to rinse it, you have to remove the insects or something. You have to make sure the data is clean, you have to make sure the data is valid, first of all. So what do you have to do for it? You have to check for mistakes in the data. Data is not always right, it's always unstructured. It may be unstructured, it may be semi-structured, it may be there may be errors, there may be numericals in place of categorical values, there may be some ASCII values, there may be some Chinese language in between, who knows, like there may be some misspelled words, there may be some other languages, there may be some other symbols inside it, which any algorithm will tend to have some trouble understanding. I never say that a machine learning cannot understand anything. It will tend to have some trouble understanding it. So you have to ensure the data has no mistakes in it. There are some mechanisms to find out, which we'll see later. So the first thing that you have to do is to clean your data, right? So then, it should not have any empty values, because empty values doesn't mean anything. You don't have to pull out your trigger just for without any bullets. You just have to make sure there are no null values, there is no unnecessary data, or there is no repetitive data. Why do you have to do it? Why do, if someone comes and start talking to you, Yashwant, I want to tell you something, that's all. He's not telling me anything. So there is no value for it. There is nothing that I'm going to understand from them. There is nothing that is gonna get me anything or get them anything. So null values should not be there, and there should not be any mistakes available there, and unnecessary data. If someone comes me and tells me something irrelevant for me at all about their own life and their own problems, maybe if they are my friend or if they matter to me, I may listen. But if some stranger comes to and start speaking to me about some random thing that I don't even know what is happening there, will it be actually necessary for me? Will it be useful for me? Do I have anything to do with it? No. So unnecessary data, there will be tons of unnecessary data sometimes, which you have to clean by yourself. You have to make sure the data is not present in that data, and repetitive data. So repetitive data, of course, you don't have to fill up the same line for thousands of times and make the algorithm confuse what you are gonna give it. So the second step would be data cleaning, which involves lot of other techniques to make sure data is right for you and data is ready to go for a model. Next come data manipulation. So this is a very creative step where you change the formats of the data, you change the structure of the data, you change the capability of the data, and you tend to create some kind of form towards it. You tend to create some kind of structure towards it. You tend to create some usefulness towards the data. So data manipulation techniques are essential to make sure that the data that you have taken is presentable, is useful, is gonna make a remarkable effect in machine learning models, is gonna make you some changes in the way the machine learning thinks. For example, if I just give some random data without any modeling or without any manipulating, if there are thousands of data, thousands of rows which has no meaning at all, I may tend to give some numerics towards it. I may tend to give some symbols towards it. I may tend to give some nomenclature towards it, so that the machine learning will understand what the data is talking about or how the data has to be replicated. So we will see what the manipulation techniques are, because it's very hard to explain the manipulation. It will better to show you the manipulation, how the things that can be worked out. So next comes data understanding, checking the patterns, similarities, conditions, doing some experiments on it, checking the statistics, rules, and other info. It's like, this is where maximum of data science or data analytics parts come into picture. So you have to find out what are the similarities in the data, what are the differences in the data, what kind of conditions will give you better output. As a developer, these things are essential for you to start understanding. You can say, why do I have to do all these things? Because algorithm is not built on its own. You have to start building the algorithm. You are creating the algorithm. You are trying to make the machine understand. So when you are trying to make the machine understand, first you understand for yourself. Okay, so you start developing the features that are important. You start making sure that the data is right. You start creating your own scores, you start creating your own similarities, you start creating your own conditions. So once you are clear with the conditions that are present inside the data, you can understand what kind of algorithm is required and when it is required. So once, if you don't have any clarity about what is happening inside the data, how will you even decide which type of algorithm to go and what do you want to do with the data? So that is the reason data manipulation and data understanding has to be done in the first place, to make sure that you understand the data for going to the next steps. Okay, so there is one more topic called as data sampling, where you don't have to use all the data that has been presented to you. You can take a sample of the data and try to function few algorithms towards it. If things are going well, you can try to replicate it for the complete data. It's just like, you don't have to eat all the rice to make sure, the rice is good or not. You just have to take few samples of the rice and you can check whether the rice is cooked or not. The same way, you can just take few data and try to understand what is happening in the data and, understand the whole data. So next comes few feature extraction techniques. As I have already told you, features are very important in all of these categories. So how do you make it matter so much? What do you do to make sure the existing data is going to float towards a model in a very subsequent manner? So what is that you're going to make the data so exciting about? These are the features that actually matter. So how do you get those things? So now there are things like replications, there are things like derivations, there are things like normalization, right? So normalization, and there are some equations that tend to answer these kind of questions. But how? So now you have this understanding, right? So now once you have the understanding of the data, you can simply tell what kind of features are actually important and what are the things that are giving you bad results. So once you start understanding the data and once you start manipulating the data, what you have got, right, now you will dissolve the data for yourself and you will try to create some analysis towards it. So now that will help you, or the model, the algorithms, the understanding will itself help you to pick some features, right? The data understanding that you have just shown, the patterns and the similarities, the conditions that you have just checked towards the data will lead you towards few features which are important and will let you know the features that are not important. So you will get a clarity, you will get a distinction, you will get a considerable amount of inputs which are required for data modeling, right? So there are a lot of other steps involved, as I clearly mentioned here: normalization, min-max, scalar. So these are the techniques that you use for developing a feature. You don't always use the raw features for the machine learning model. Sometimes you may have to use some kind of functions on it. You might have to change the data into some other format. For example, let's say, in any class example, right? If you are going to compare the student marks, right, how are you going to do it? Are you going to test few people with scores 1 to 10, and see, for example, there are 100 people. You're going to use 0 to 100 marks for all of them, right? Or if I'm going to do like this, I'm going to take 20 people and I'm going to make them marks for 0 to 10. I'm going to just make sure that they're getting 9 out of 10, 8 out of 10. The exam is only for 10 marks. I'm going to take next 20 people and their exam is for 30 marks. I'm going to take next 20 people and their exam is for 70 marks. And I'm going to take next 20 people and their exam is for 100 marks. Is this the right way to test people? It is not. So if I'm gonna do this way, this is not all right. I have to normalize these things. All the people in the class have to have an examination which is out of 100 marks. I cannot split people and make sure that few people are writing only for 10 marks and few people are writing only for 50 marks, few people are writing for 100 marks. This is not normalization, right? So normalization is something when you have a discrete amount of data, when you have different types of data, you have to have some kind of unique pattern or unique limitations towards all the parameters or all the features, right? So these kind of things you will get familiar. This is just one example. There are multiple things that you have to change your data for and data to in order to achieve few kind of extraction methods, right? So now again, so data visualization. Now once you are good with your features, now you have understood your importance, now you have extracted your features. Now you have normalized everything. Now you have the data ready for your modeling. You have to visualize your data in order to make some pattern recognitions. So why it's visualization is just for your understanding. So you have already done the understanding here, but this understanding is statistical understanding, right? So but the visualization that you are doing is for your experimental understanding, right? So the experiment that you are taking place, you have a bigger picture, you have a very wider picture, you have a very interesting insights towards the data, you are having very good reasons for a particular model to develop. We just can't look at the numericals and information to decide whatever is going on. Sometimes the numerics may fool you, the numerics may tend to deviate you in another formats. So visualization will help you decide in a very particular manner which type of data and what kind of algorithm can be useful. So whatever we are trying to do, these things we are trying to do because we are trying to do some model. So final approach is to do some model. So to create a machine learning model, these are the back steps that have to be involved to decide which type of algorithm has to be used. So next comes feature selection. Although I have just mentioned that you have to extract the features and keep features for important features, you may not need all the features to start developing it. Some may be having negative effect on it, some may be having zero effect on the output. So now you have to select features that matters and you have to start building on it. So next, so we'll start talking about one more important thing, which is called data frame here. So now in Python, we say data frame, which is a tabular structure or two-dimensional representation of data, whatever you have. So now what happens is everything is gonna get stored in data frame, and the conversion of data frame to array and array to data frame is going to happen very frequently. And when you are actually modeling data, it prefers to have array kind of mechanisms, or it prefers to have arrays in the data formats to make sure the model is going right. So now you have your feature selected. Now the model is going to work and you have to choose an algorithm and apply the model. This is a very simple step and very important step where you have to choose an algorithm and you have to apply for the complete features that you have just selected. Now what happens once the modeling is done, you have to check for model analysis, which means you have to check the model efficiency, you have to check the model conditions. And now what does that mean? You have to check its accuracy. You have to check its efficiency, you have to check its data loss. You have to check whether the data model is working right or wrong, whether it is according to your expectations or not, whether it is according to the model expectations or not, whether it is according to the original data or not. There are a lot of other things that you have to keep monitoring before you actually implement this in the real world. Correct? So before you just go to the final step of the deployments, there are a lot of checks that are required. If the model is not giving you a perfect accuracy, you go back, train again, you change some parameters, you add some parameters, you change the features, you understand the data better, and come back again, do the model again and analyze again. So you can do model analysis multiple number of times until you are satisfied with the data. And once you're satisfied with the data, then you can go for the deployment. So yesterday also, the example, like when can be your when can you probably die using Google. So he just mentioned that first of all, when he started looking at the data, at the news, the accuracy was 40%, then the accuracy was 70%, then now it is 95%. So what is happening there is they're developing the model, they're checking the model analysis, they're checking the model efficiency. The model efficiency was 40% in the initial stages of the Google, then the model efficiency was 70%, then the model efficiency is 90%. So the increasing efficiency, the better the model, the efficiency better, the accuracy is better, the data loss is low. So these kind of checks that are required for the data modeling analysis have to be done to ensure that the model you have done is right. And then once you are satisfied with the results, good to go. You're good to go. You can deploy this in real world. So this is a picture that is gonna get involved inside the machine learning, from data extraction, data cleaning, data manipulation, data understanding, feature extraction, visualization, feature selection, modeling, model analysis, and deployment. As simple as that. So now we're gonna see. You're gonna bear with me for one more slide, because this is actually the machine learning process that I'm gonna speak with you, not just any understanding. This is an ML model. So now let's come back to machine learning terms, where I started telling you things like prediction, classification, organization, and all such things. So now let's say we have data. As we all know, what are the types of data? Structured data, unstructured data, basically, right? Structured data will have certain kind of labels assigned to it. Unstructured data will have random data. So this is clear, right? So any unstructured data will have random data. Any structured data will have some kind of label data. So what we can do here is we'll take a very basic examples, and we'll try to figure out what is happening around the clock in machine learning and artificial intelligence. So now this labeled data, which is assigned towards when you are using it in machine learning, we call it as the structured data as supervised data. Now we have supervised models, and if you are using your random data, you have unsupervised models. So what are these things? We have few regressions, classifications. Regression means you all know stock prediction, right? Your bank balance, or loan prediction. How much loan that you are eligible to get, and credit card fraud. How much the limitations that you have for the next month. What are the things that you can probably do for the next coming? How much money you can spend for the next coming days? These are the predictions based on few actual numerical values. So those things are called regressions. And the classifications, which means you're able to classify things into categories. Maybe a couple of categories, maybe more than two categories, multiple categories, whatever. You're classifying things. You have certain kind of fixed amount of outputs. You have some kind of fixed numerical of outputs, or you may have some kind of categorical outputs there. So the output is defined, the labels are defined, the results are defined. So we can say labels are assigned and results are defined. So here in the random data, undefined, there are no defined results. It's all clumsy, it's all messed up, it's all random. There is no proper structure towards it. So now what we can do, for these things, there are called as nearest neighbors. KNN, a support vector machine. There are a lot of other things that you can do for dealing with unsupervised method. So let's see few of the supervised methods for today. So this is a difference between so now this data can be split into two categories, and the assigned labels that can be divided as supervised models, and supervised models can be classified as regression and classification. Now, depending upon the data, if it is unstructured, you have random data which are having undefined results, which are unsupervised models, and you have a few things to make sure that the unsupervised models also work better. Let's not talk about much about these models and stuff, and we quickly go back to how actually the model, this regression works, how actually you can start applying a model mechanism. I just want you to let you know the model mechanism, what happens inside the model. So I hope things until now things are very clear. The steps involved, what are the data that has to be taken, how the data has to be understood, what are the use case mechanism that has to be learned, how the Python has to be involved, what are the technical things, and a lot more other stuff. Now let's see how you're gonna make a data involved inside it. All right. So how are you gonna make data involved? Yes, boom, you got the data, you got your X values, you got some CSV formats. I think it's better to show it to you with one example. Let me know if it's visible for you. How about now? Hello?
Yes, yes, Sai.
Can
Yes,
you
it
hear me
is.
now?
Yes, yes.
Thank you so much. So now packages is done. Now what you have to do is to import your data. So I have this CSV file now. All right. So I hope you all remember the steps that have been discussed before, and now you have your data ready in your CSV file. Now what I'm doing, I'm importing the data into this variable. So the moment I start importing the data, here comes the Python assignment and Python manipulation. So this is why Python is so important. Python, or for that sake, any kind of programming language is so important. So you have to have the variable ready to make sure the data is stored inside it. And then as you can see here, the data is stored in data frame format. Pandas core frame dot data frame. So this is a 2D representation of your data in a data frame. So whatever data is there in your Excel format has been represented in your data frame format, in that is stored in your variable. All right. So now what we are trying to do, so we are trying to understand, we are trying to see what is the type of data. So the data is having two columns, years of experience and salary. What we are dealing here is a basic machine learning application, is a basic machine learning regression. We're just trying to predict a person's salary based on his experience. As simple as that. There is not too there is no complexity in this. It's just predicting a person's salary based on his experience. So how is that going to happen? So instead of a person sitting as a HR sitting there and trying to figure out the salary that has to be given for let's say 1 lakh people in their company, how much time it will take for him to sit and open the resumes of all the people and see, okay, this person, this salary, this person, like it's total waste of time. It's a heavy process. So take it as a big picture. An MNC, lakhs and lakhs of people, lakhs and employees. So they have to make sure everyone's salary is predicted. So everyone have to have the salary given for the next coming months based on their experience, based on their number of working days, based on their efforts, based on the timings, based on the projects they have done. So here we have only one parameter. So there can be multiple parameters. That is why I told you the features are very important. Right. So the features are very important. Though we have only one feature, which is called years of experience. So now what we have, this is a feature, and what is our output? The salary. So we have the salary. How much the salary is for the next coming month, or the first next 3 months, or for the next year, is the output. Here what we can say, this as an independent variable and this as a dependent variable. Let's start from there. Okay. So because the salary is depending upon years of experience. So years of experience is not any depending upon anything. It's independent. I can have any years of experience I want. I have. It doesn't depend upon anything. I have 4 years of experience. You have 3 years of experience. It's not depending. But my salary is dependent, right? If it is my 4 years, the salary is one particular amount, and if it's 10 years, the salary is one particular amount. So it's depending upon the years of experience. So let's say independent values of X and the dependent values as Y. All right. So now let's do some data manipulation techniques. I'm just assigning only one column, that is years of experience, to the variable X. So even this is a simple manipulation technique. So this is how you manipulate your data. You change the number of columns, you change up the columns front and back. You decrease the size, you increase the size, you change the categories, you check the categories. Now I have this in float format. If I want this in numerical formats, I have to change it into numericals, right? And then here I'm trying to change data set from data frame to array format, dot values to array format. So these all the things comes under manipulation techniques. Why do you have to do it? You have to do it because you have model coming up, and the model can understand arrays pretty well. So you're checking the dimensions here. This is data understanding. It may be a single line over here because it's a very naive example. But when it goes to a complex examples, or if it goes to AI algorithm, if it goes to a very much bigger use cases, This understanding, this x dot n dimension is not just one line. It has the understanding which you have to do is much more complex than this. Next, you are checking what type it is, and you are again using data manipulation techniques to assign variable y, which is salary. So you're assigning variable y to salary as dependent variable. So x is independent and y is dependent. So clear. Now again we are changing to arrays using data manipulation techniques. Now one important step here is training and testing. I can take this example of your school exams, or in that case any exam. So your teacher will try to teach you a lesson for almost a month or 2 months, and they will repetitively tell you few topics. They will try to by heart you few questions and answers. They will explain you things, and at some point they are going to test you, unit test, half yearly, or any kind of slip test or anything. So what are they trying to do actually? They have trained you on one particular concept or one particular subject for months together, and now they want to see whether whatever they have taught has been understood or not. So now they're testing by giving you a test, giving you an exam. So same way, you have to divide few things. So what they'll do, based upon the techniques they have taught you, based upon the knowledge they have gave you, they'll try to test you using different scenarios. Let's take a math example. Do the same formulas or same numbers will be repeated in your final exams? No, right? So they will only test you the derivation. They will only train you with a few topics and few techniques. You have to figure out how to use those techniques towards the new data as well. When the new type of formula is given, when the new type of numericals are given, you have to be in a position to use those derivations in the new data. That is how examination works, right? So in the same way, you have to split the data into two parts, training and testing. So first of all, you have to train your data pretty properly, very well. So now that it's like, for 1 year experience, this amount of salary, 2 years of experience, this amount of salary, 3 years of experience, this amount of salary. So model will understand the situation over there, and it will try to test the results afterwards. So now for that, what we are using one more called as train test split, which is there in sklearn. Sklearn is one important scikit-learn package to ensure the optical calculations which are involved in all the types of machine learning use cases. So here we are using train test split, right? So using this train test split, I'm dividing my x and y values into x train, x test, y train, and y test. So what does that mean? So let me share it you with uh, one. Okay, so let me create a box for you, and I hope it will be very clear if this example. So yeah, x and y. I can say train here. Okay, let's say x. Let's take this to next. So now you did understand the difference between x and y, no? X is independent, y is dependent. So now what is happening here? So years of experience. So for 1 year, maybe the package is 3 lakhs. So what is happening here? It is trying to understand okay, 1 comma 2. Let's say 1 comma 2 comma 3 years. So 3 comma 6 comma 10 lakhs package. So respectively. So for 1 year 3 lakhs, for 2 years 6 lakhs, 3 years 10 lakhs package. So now this pattern is present in X. So the number of years is X and the Y that is been there. I mean the salary is this. This will get trained over and over again. Next, when it comes to test, the teacher will ask, okay, now how about 3 years? How about 5 years? How about 8 years? Right? It is trying to test what is been given previously. So now he might answer as per the training set, what must be the salary for 3 years? 10 lakhs. But he may say, so for 3 years, 11, and for 5 years, 15, 14, maybe, and for 8 years of experience, 20 lakhs of package. So this is testing that is getting happen. So now we have to test it. Like, is it correct or not? Whatever the things are there here, we have to test it. This may be the values that are being present. Okay, I'll tell you one more thing. This is training, and here let's assume that this has been data that has been already given. So for example, 4 years, let's say. For 4 years, 11 lakhs, 5 years, 14 lakhs, 8 years, 20 lakhs. Now we have this test information, but we do not use this test information. I'll tell you why. We do not use this test information. We'll keep this information hidden. Okay, we'll keep this information hidden, and now we will try to predict something. While predicting, these are the questions that are being asked in the exam, and these are the answers that are actual answers. The teacher already know, but you don't know. Now it is trying to test you. For 4 and 5 and 8 years correspondingly, what is your answer? Maybe you have given for 11, 15, and 21. Let's say 20 only. So now what is happening here? This 11, 14, and 20 are the actual test results that we already have, but we are predicting the same test results, and we are getting one more output called 11, 15, and 20. Over here, there is an error. See, instead of 14 for 5 years, it is predicting 15. So this is called error. But instead of 11 and 20, the same is getting predicted. So this is called accuracy. Here the accuracy is 2 by 3. The error is 1 by 3. Right? So instead of 14 is predicting 15. So this is how you have to test it. So the testing is being done between 11, 14, and 20 and 11, 15, and 20. So when you compare these two results, these are the values that are already there in the hands of teacher, that the teacher already know the answers. But in the examination, these are the questions that are given, and this is the prediction is the answer that you wrote. You have written correct answer for 2 things, and you have mistakenly written for 1 answer. That means you have got 2 marks out of 3, 80 marks out of 100. So now you can understand the difference between accuracy and efficiency. So the efficiency may be 80%, the accuracy is 80%, or 2 by 3. Right? So this is how any basic machine learning model works. So this may be a linear regression problem, right? Simple linear regression problem. Let it be complex or multilinear regression problem. You just have multiple parameters. If it is a polynomial regression, the difference between the relation between x and y will be going exponentially. Instead of something very nominal, it will go exponentially. For 1, 2, for 2, 8, right? For 3, 24, it will go exponentially. It will increase very drastically. The relationship between x and y will be very drastic in polynomial regression. For multinomial regression, you will have multiple x values, which means x1, x2, x3, x4 for only one y. That is called multilinear regression. And when you come for logistic regression or classification, instead of all these values, you have 0 or 1 or true or false, right? Yes or no. Or for example, buy car, cat or dog. So these are the examples of classification problems, right? What is this example? 3, 6, 10. This is an example of regression. These things 0, 1, like 0, 1, true or false are the problems of classification. So these are the differences of models that you have. These are the types of models that you've come across. But basically, what you have to do, you have to train it, test it, predict it. Train it, test it, predict it. Train it, test it, predict it. After prediction, find the accuracy. After prediction, find the accuracy. Efficiency, accuracy, efficiency, accuracy, efficiency. So the inputs and the outputs may differ according to the situation, according to the condition, according to the use case. So now you might have an understanding the importance of data understanding. So when is that you have to decide you have to use 0 or 1? When is that you have to do classification? When is that you have to do regression? For what type of data do you have to use regression? For what type of data do you have to do classification? For what type of data you have to do unsupervised learning mechanisms? So if you do not have a understanding of data, you do not decide, you cannot decide what type of algorithm it is, what the data is, how the data is flowing. Okay. So now let's say let's come back to the problem statement and yeah. So now we have it's clear about testing, right? Train, testing, and prediction. So why, how the training is done, how the testing is done, and how the prediction is done. I think it's clear. Okay. So now we have the data splitting. So how many values to test? If we have 0.2, that means train 80 data and test 20 data. Okay. So now next what is going to happen is here I am calling linear regression. Okay, linear regression is a function. You can say it as a function, you can say it as an algorithm. All right, you can call it as a complex package or whatever. So this linear regression package or the function or the algorithm, I'm calling towards it and storing it is a variable. Again, it comes to a variable. So the variable has the understanding of linear function, the linear function or the linear regression, which means y is equals to mx plus c. You must have come across a basic equation called as y is equals to mx plus c, where there is a considerable amount of relationship between x and y. When the x increases, automatically y increases. When the x decreases, y decreases. Based on the slope value, constant value, y is equals to mx plus c. So it's a basic equation, right? So it is what is going to happen inside this linear regression. All right, so it will understand the relationship between x and y that is been present over here. Technically speaking, x train and y train, not x and y directly. You're gonna train x value and you're gonna train y value, which means for the particular amount of x train data, there is certain amount of y train output, right? For some particular kind of x train data, there is particular amount of y train output. So this linear regression will tend to fit this understanding, okay, into the variable. And now what we can do is we can use this variable and simply call the prediction function to predict that test values. Which test values? X test values. So now if you're going to test X test values, you're going to get some outputs which are y predict. So these are the y predicted values and these are all the y test values which you already have, which the teacher already has, and these are the things that you wrote in your examination sheet, answer sheet. So these are the predicted values, and these are the values that you already have. So this is the comparison which will tell you and which will give you marks for the algorithm. So when you go back to the starting conversations of our class or of our lecture, so we spoke about human brain creating some kind of enzymes when you feel happy. It will give you some happy hormones when you are liking something or liking someone. So here it will produce accuracy like enzymes. So the better the accuracy, the better the enzyme, you can say. So the enzyme is accuracy here. So when you have the accuracy better, that means your model is going in a very good way. So the accuracy is better, that the enzyme is good, that the model is feeling good. You can proceed. You can proceed. You can see, we have something called as best fit line over here, which means the complete understanding of the training, right, is going in this format, and the data that has been present over here is predicted values. Okay, so the data whatever are there in green color are predicted values. The red line that is going is best fit line. That means based on the training data, there is an equation, there is a simple line equation that has been formed using the training data. The training is having x and y, no, x and y. So what can be the thing which x and y is equals to mx plus c. So what does this equation have? Only two things, x and y. So we also have two things, x and y. So using these two things, you can create a simple line, right? This is a simple line equation. This is a simple line equation. So in simple line equation, we are creating a simple line. Okay, this is that line that has been created using x and y train data. So now using x and y train data, this is the line that has been created. And now we are plotting the test data, or we can say predicted data, towards the side of this line. So now what we can say, it's almost close. So the predictions that are being given, the prediction that has been given, just a second. Yeah. The prediction that has been given over here are almost near to 40, 37, 12,000, 12,000, 64, 57, 63, 63, 63, 115, 115, 107, 109. So they're almost near. So the predictions are correct. So we have certain kind of relationship between these things. So we can find the accuracies, we can find some kind of efficiency by using few more packages. You don't have to do much about it. You just have to call a function, okay, and give these two values, y predict, y test. The moment you give these two values as parameters for that function, you will have some accuracy, you will have some scores, you will have some FC scores, ROC curves, and much more things. So that's yeah. So error is difference between predicted and actual values. So these are the predicted values and these are the actual values. Next, we have something called as performance, calculation, confusion matrix, scores, loss functions, accuracy, specificity, sensitivity, ROC curves, AUC curves, precision, recall, F1 score. These are all model analysis. These are all involved in model analysis. So, sorry. Yes. Can you see performance, calculation, confusion matrix, scores, loss functions, accuracy, specificity, and F1 scores. So you have much more things like this. You have a lot of other things, and once if you go with details, it's gonna take eat up a lot more time. So let's not go to calculations of how accuracy is calculated and root mean square errors, lot of error finding mechanisms, lot of model analysis mechanisms, and much more things are there. So I can show you different types of algorithms and different types of outputs that are there. So for example, let's say this here we are predicting using, okay, this is a multiple linear regression. Okay, this is multiple linear regression where we have spent, administration spent, marketing spent. So they are trying to figure out what we can say, profit and loss for a company, where they're trying to calculate how much money is spent on R&D, how much money is spent on administration, how much is spent on marketing, and what is their profit. Okay, so these are multiple fields, and you have, this is the kind of visualization you do before going into your model, and you tend to create some models, and then you go and find some visualizations again, then you go for accuracies. Let me show you accuracies. So yeah, see, accuracy score. Let us do this for regression as well. Okay, we do have it. Okay. So yeah, this is our testing results. Then mean square root error. Then finding the R2 square, or we can say accuracy. Okay, accuracy score is not defined. Just have to import the package. So simple as that. We have to import the package, and boom, you can ready to have some calculations of accuracy. What's been happening here? Okay, there might be some difference in data targets. Never mind. So R2 square is also a calculation of how accuracy works, which is having 98% accuracy currently. As you can see, the R2 square is 92%. The same you will have the accuracy scores, evaluation matrices, and all such things. Now let's see for, so this is a random forest and decision tree. These are two types of classifications, you can say, which means you have multiple conditions, not one, not two. You have multiple conditions to choose from, and then you're not sure how the data is going. So if you can see here, the data is very random. So for these kind of data, decision tree and random forest will help you to understand and choose the output very cleverly and clearly. Okay, so I guess with this understanding, with this basic understanding, I can conclude my point of view towards the experiments. And if you want to start your practice sessions, you can. I'll be online for now, if it is allowed, and I can help you to execute these things on your own. And how can we proceed now, Namrata ma'am? Can you guide me from here?
Yes, Sai, we didn't plan this. I mean,
Yeah. So
the
can
other
we?
side, how they are going to do the practical sessions. So
Okay.
tomorrow we will send
Yeah.
them the guidelines. If they want to execute, they can share the screen, and if they have any doubts.
Yeah, let's do one thing. I'll share them the links of Anaconda requirements
Yeah,
and
sure.
the code
Just
as
shoot.
well. So they can, before coming tomorrow, they can execute and they can try. They can try executing, and they can come to the session tomorrow, so that we can monitor.
Now, participants, if you have any doubts, you can unmute yourself, and then you can ask the queries to the resource person. Participants,
Good afternoon, sir.
Yeah, very good afternoon.
So it is possible to design linear regression using neural networks, sir?
Yes, we can. Neural networks is regression and neural networks are, very contradictory topics. Uh, let's say one branch or one leaf of complete tree is a linear regression, and the complete tree is an artificial neural network, a neural network. So you're just asking, yeah, we can. Simply, as simple to say, we can.
Thank you, sir. It's clear, sir, for your clarification.
The one more thing I can tell you is, if you combine lots and lots of regressions, that is nothing but a neural network. So as simple as that.
Yeah, sir. It's clear, sir.
Good afternoon, sir.
Yes.
I have one doubt, and I'll share the how we are going to divide test data and training data, sir.
Okay. How in the sense? 1 second. I'll show it to you. So we do have. Okay. So I have showed you some example using the square bracket, right? Like square image, right? So you have your x values and y value, right? Dependent and independent values. X is independent,
Yes,
and y is dependent value. So now you have to decide what has to be the testing set. Your ma'am have given you, for example, there are 10 questions in your textbook, and your teacher in your school have just prepared you for 8 questions, and she's expecting you to fill up those 2 questions on your own. She's expecting you to think about it and answer 2 more questions. All right, so here what is happening is 80% of the data is given for training. Training means both x and y. All right, so you need to train x with respect to y and y with respect to x. That means for this particular amount of years of experience, this is the salary. So 1 year this salary, 2 years this salary, 3 years this salary. You have to understand the pattern. For example, if you are a computer science engineer, if you have 1 year of experience, you will have certain amount of salary. If you are a chartered accountant, if you have 1 year of experience, you have one particular amount of salary. If you are manager, if you have 1 year of experience, if you have one particular amount of salary. If you are an artist, or if you are a dancer, if you have 1 year of experience, you have one amount of salary. So it varies from situation to situation. That is the reason you have to understand in which domain for 1 year of experience, how much is it? For 2 years, how much is it? That understanding is required. How it is achieved? For X train, what is the Y train? For 1 year, what is the salary? For 2 year, what is the salary? For 3 year, what is the salary? So for one particular given independent value in X train, what is the value in Y train? So now what you are going to do next? You're going to test some results, and then check it with Y test.
Sir, I have one more doubt. Why we are taking the test set percentage as 20? Can we take another percentage like 40 or 60?
Yeah, you can take 33. You can take. It should not exceed 50. Okay, it should not exceed 50 because it will be a very overfitting problem.
Okay.
You can take 60, 40, you can take 70, 30. Ratio can be flexible. Random state is one parameter where you have to take first 20% or
randomly 20% or in between 20%. There is a lot of other things that are involved in those things. You can take any number of random things.
Thank you, sir.
Yes, participants, any other, if you have any queries, you can unmute yourself and ask. Yes. You can also post your questions in the chat box. If you have any issues with your audio. Okay. So, Sai Yaswanth, sir, thank you for taking a wonderful session. You have explained very clearly the basics, from the basic thing to how to implement and what are all the steps to develop a application that can predict the things using the artificial intelligence and machine learning algorithms. So
Right.
thank you, sir. Thank you once again. And it was a very nice session. It was a very much clear and understandable session, sir.
Thank you so much. Thank you so much, guys. Thank you for your patience and thank you for
sir.
attending this. Bye-bye.
Thank you. Tomorrow, see you.
Let's connect back tomorrow. Thank you.
Thank you, sir. Participants, fill the feedback form. And thank you. Tomorrow we'll meet again.